Hello everyone, I'm Lara from Proxima, and today I will host this embedded workshop. Today, Miguel Angel Gonzalez Rodriguez from Javeriana Bogotá University will present the talk Computer Vision in Embedded Systems using micro-ROS. So, Miguel Angel, are you ready?
Yes. Can you hear me?
Yes.
Okay.
Now I think that you can present.
Okay. Let me. Here. Okay, there. So, good morning. Good morning, everyone. My name is Miguel Angel Gonzalez, and today, well, I'm going to present about computer vision in embedded system using micro-ROS. Talking a little about me. I'm Miguel Angel Gonzalez. I'm an active student at Universidad Javeriana in Mechatronic and System Engineering, and I'm actually nowadays the IEEE, the Javeriana chairman of the Institute of Electric and Electronic Engineers. So, to begin with this presentation, I'm going to explain a little bit about the technologies we are using. So we're going to start telling what is micro-ROS. I know in a deeper level, this has a deeper definition, but micro-ROS is an implementation of ROS2 for microcontrollers, so we can use publisher and subscribers, service and client. Why micro-ROS for microcontrollers? Why we need to use microcontrollers? First one, because they are found in most robotic projects nowadays. Second, they are low cost compared to computers or embedded systems like Raspberry, Jetson Nano. Also, they have a lower power consumption and they have compact size. So, it is no surprise to no one the fact that actually artificial intelligence is one of the pillars to technology, because with these technologies we can train models to predict data, to interact with our environment, and different sort of things we can make with these technologies. For microcontrollers, we can find two principal libraries like TinyML or TensorFlow Lite. So we can use artificial intelligence on embedded system. But as we all know, this is not the same of using the full model like TensorFlow on a computer. But we also know microcontrollers can't run these complex AI systems. So for this project, I made, let me check if I can have a better quality now. I made a little project to try to run a computer vision system on a server and using the embedded system ESP32 to run micro-ROS, ask my computer as if it was a server to check the camera image, check if I have the hand open or closed. ROS2 Humble is analyzing this image using OpenCV and CV Bridge, and he returns a number telling me if I have the hand opened or closed. The advantage that this gives us is that we can run more complex systems than we can run embedded on the ESP32. We can make computer vision, as I said before, in an embedded system using TensorFlow Lite, but it doesn't have the capabilities that have a computer with a graphic card and a better processor. But I made an update of this project to make another comparisons using cloud systems. So to begin with this, I'm going to explain a little bit about artificial intelligence and computing and cloud computing. These are the two pillars of digitalization nowadays. Why? With artificial intelligence, we can create computer systems capable of performing tasks that requires human intelligence. As I said before, interacting with the system using like computer vision or natural language processing, or also to predict data. And cloud computing gives us availability of on-demand computing resources over service over internet. So this means we can, as long as we have internet, we can use software wherever we are. Actually, we can check that nowadays 78% of business with AI projects have these systems implemented on the cloud. Which are the advantages and disadvantages using micro-ROS with AI on the cloud give us? First one, as an advantage, we have more flexibility and greater computing power. Why? Because with these cloud systems, we can have elastic instances that we can change their hardware, make greater their CPU, their graphic card requirements, so we can, at the moment that we are using the system, upgrade their computational power. Secondly, when we use just micro-ROS and the complex systems on the cloud, we, as a physical device, we only have ESP that has a lower energy consumption. And third advantage, it is most cost effective in the short term. Using Colombian prices for these devices, the Huawei Cloud instance I created for this project, it cost me around 0.01 cents the hour, and a Raspberry Pi costs around 200,000 pesos, Colombian pesos. So this means we will have to run this instance for around 6 months long without shutting it down to make the same cost that have buying the Raspberry. And also, if we buy a Jetson Nano, we will have to run this cloud for around 5 years to make the same price that we have with this device. But the disadvantages we have of using cloud system with AI to communicate to micro-ROS and make these complex systems is that first, the system get dependent to Wi-Fi. This means that if we have no network connection, the program will not work. Second, if we doesn't have a stable Wi-Fi network, it can experience high latency. And the last one, this requires enhanced security. Why? Because if we have a robot with a microcontroller like ESP32 with micro-ROS and a Raspberry Pi with ROS to Humble, we can use serial to communicate and we can encapsulate the system. But if we use cloud systems, we are having a connection to a network. So this means it is possible that we can get a man-in-the-middle attack or connect to the micro-ROS port and send another messages we don't want to receive. So to show a little project that make this to connect micro-ROS to cloud systems, I made a little program that is a rock, paper, scissors game using Huawei Cloud to analyze the ESP32 image and micro-ROS to send the image data to this cloud system. So as we can see, we have an OLED screen that uses a I2C protocol to communicate, where I can check if the system shows rock, paper, or scissors. The ESP32 camera checks what movement I'm making, compress the image to image compress topic message in micro-ROS to send to my cloud instance that has a Docker with ROS to Humble running. This system uses OpenCV and CV Bridge to decompress the image and check the option I'm doing and return the message to my ESP32. Here we can see the hardware connections. Hardware is very simple, just a button, the SP32 cam, and an OLED screen. And the software architecture looks like this, where we have the user that utilize the SP32 cam in a local network. This SP32 cam create the instance in micro-ROS to send the image to Huawei Cloud Docker container. The subscriber checks the message, decompress it to make it an image for OpenCV, and this image gets analyzed to the publisher, send back the answer of 0 if it is work, 1 if it is paper, and 2 if it is iSource. So this is all that I have for today, and I would like, before ending the presentation, to talk a little more about the other RAS Javeriana projects, the student group I'm with. And we are actually developing with ROS also a mobile robot that the controller is using also micro-ROS, and it has a Raspberry Pi with ROS Humble for make autonomous navigation. And another project is from one of my friends that developed Flatboat. Is a Kubernetes implementation for orchestrating ROS2 packages. So also, if you want to check the repositories for the both projects I just showed, you can check this link. And also I have more projects about ROS2 with computer vision or artificial intelligence.
Okay, thank you very much for the presentation. Very interesting. So any question?
I have some questions. I am curious because I am test. Can you hear me correctly?
Yes.
Okay, perfect.
Yes,
I'm interested.
perfect.
You are using in the last video. Are you using the SP32 camera, right?
Yes.
And it is easy to work with Microsoft. This is working well, and you can use the full. Sorry, the full. I don't have the word. The full dimension of the camera or the full image of the camera. You can send.
Yes. Well, I don't know what is the word. I selected to use ESP32 camera because, well, first it have a camera integrated, so I don't have to make the thing that I made in the first project to use an external camera with a computer, because that doesn't encapsulate my physical system. And the advantage I saw to use ESP32 also was the fact that it has two cores, so I can have one core just looking for the image to make the camera work on its own, and the other core with concurrency, I can run the micro-ROS packages, and it can check the full image, send the full image. But I just had, well, when I made that, I had one small problem, and was the fact that when I created my cloud instance, I didn't give it enough bandwidth, so it didn't receive all messages. But when I use it on local and when I in the cloud put more bandwidth, it worked without problem.
Nice. Do you have, what is the latency that you have or the response that you have between using the local computer and the cloud with the camera in the SP32?
Okay, I didn't check for metrics. Maybe I should do that to have a specific value reference for this.
But do you have an idea if there are maybe 1 second or less 1 second, or maybe 5 seconds or 10 seconds?
Okay, it was less than 1 second. Let me share again here. In the video, we can see when I change like the pose, the how fast it is sending the messages. For example, when I made paper, like less than a second, it sends the messages. But I'm not
Nice.
sure exactly how much time.
Okay, nice, very nice. I am working a project with the robots, and I am interested in try the camera, and well, and I think that is very cool, the idea to use the cloud to run the ROS and all the processing of that.
Thanks.
That is very nice. Well, anyway, I will ask you if I have another debut about that, because
Yeah, no
I'm
problem.
not sure how you resolve the IP with the micro-ROS, that you need to use the host IP in the micro-ROS, right? You used to put the host IP in micro-ROS to run that correctly. But well, I can ask you offline if you want.
Yes, in my Linktree QR, you can find my LinkedIn, so you can message me and I will help you with that.
Okay, nice.
Is there another
Okay.
questions?
Another question. I don't have another question.
Not for now.
Yeah, not for now, exactly.
Okay, so thanks a lot, Miguel Angel, for coming and presenting your projects. And well, that's all for today. See you in November, as in October will be at ROSCON. So if you're going to be there, we have a booth, the 10 booth, so you can come to say hello. Okay, so see you. Bye.
See you. Have a great day. Bye-bye.
Thanks a lot
Bye-bye,
for the
see you.
invitation. Bye bye.
Thank you.
Bye-bye.